Well, good morning, and thank you for joining us for part 2 of our webinar on how to sustain indoor air quality and leverage AB841 funding. We've received tons of questions at our weekly telebriefing on how to improve ventilation to prevent COVID-19. Last week, we looked at the importance of assessing your setting to determine how things are working and where the gaps are and what would be the best kinds of solutions, how to spend the smart money. This week, we're going to take a closer look at work that was done in 4 pilot sites. We had an elementary school, a middle school, a high school, and a K-12 school that participated in that study. Before we begin, I just want to let you know that you do all have the ability to unmute, but what I'd ask is that you put your questions in the chat. We'll address those questions before the end of the meeting, and then if we have time, we can let people come off mute and ask questions live if we get to that point. We're also recording this webinar, so it will be available for viewing later on. We'll follow up, sending everyone the slide deck and the link to the recorded webinar, so you can also take a look at it that way. I'd like to turn it over to Richard Doss, Senior Vice President with LifeWings Peak Performance, and he'll go ahead and introduce the rest of our panel.
Thank you, Bob. Just want to do another audio check. You can hear me okay? Okay. I want to thank everyone for taking time, especially everyone that came for 2 weeks. We had a good discussion with a really good Q&A panel and some good also follow-up emails last week. So that kind of gave us some thoughts and ideas on how we might proceed for this week. So what we'll do this week is we're going to, Dr. Altman's going to do a quick recap for us on where we kind of left off last week. And then Randy will walk us through typical assessment activities and also, what were some of the findings. We've collated a lot of information from the 5 sites plus 2 extra sites. And I think we'd be remiss if we didn't thank Liz and her team at Hemule and Dave Farkas and Dr. Potter and their team at San Ysidro, Cherie and Mr. Jaffe and the maintenance team at Vista High, and of course, Alec and all the folks down at the Monarch School for being so welcoming and so available to different schedules, because it always changes. So we will talk about some findings from the field, and then Ron will give us a bit of an overview on maintenance and monitoring systems, and then we'll have a wrap up. And today on our Q&A panel, Paulo Azevedo is going to join us from San Ysidro, and we'll also have Roger Silveira from San Jose East Side Maintenance and Facilities and Operations, providing us with some good feedback on our Q&A and our reaction panel. Just real quick reminder on our main speakers, and for those that weren't here last week, Randy Christensen, I introduced Randy from KFI Engineers. Randy's been involved with, that number's wrong, it's about more closer to 300 COVID HVAC assessments now, but nonetheless, mechanical engineering for 25 years. Also today, Ron McGuire. Ron has spent 23 years as a production engineering and maintenance guru, if you will, first at Johnson Controls, then at General Mills, but his strong suit is autonomous work systems, total productive maintenance, and he's been riding shotgun with some of the folks to try and learn what do we need in the future for monitoring and maintenance systems to achieve some of our goals and objectives. And of course, Dr. Scott Altman. Scott's been active as leading the COVID strike team at Advocate Christ Hospital. We worked together for several years, and Dr. Altman, of course, has a couple of different academic appointments in his background and works with residents and people that are learning to become physicians on a regular basis. And with that, we will have Dr. Altman give us a quick recap on where we left off last week.
Good morning, and thank everybody for attending today. So where we left off last week was talking first and foremost about the importance of safer air, including the biological risk of spreading COVID, other respiratory contaminants. We're starting to see here in Chicago a return of respiratory syncytial virus, which is normally a winter virus, but as we start getting back together again, it is being spread, and contact-based hazards. We're also trying to reduce both indoor and outdoor volatile organic compounds, air contamination with CO2 or nitrous and particulates, improving the quality of the air from a perspective of molds, mildews, humidity, and temperature control, and of course, reducing outdoor pollution, fire, smoke, and pollen, depending on where we're located, whether it's near a highway or out in the country or near farmland or high pollen areas. The tools for doing that we talked about, hardware and equipment, include striving for laminar airflow and adequate turnover rates, which may require doing some creative design ideas to retrofit old spaces. There will be some equipment that just is unreliable and unfixable and will have to be replaced. Some equipment can be repaired or upgraded and maintained in structure. And then, of course, we may need to work with our staff to provide skill support, upscale some training for enhanced air handling systems that may be more complicated than they're used to. And then the last piece is to establish a pretty clearly defined protocols and oversight system to make sure that our systems are properly maintained and upgraded and serviced. Next slide. So the goal here is not just to improve the air for the sake of virus protection. It's been pretty clearly proven that cleaner air results in fewer lost work time for students and educators, lower medical and health insurance costs and claims, improved academic achievement scores for students, and lower workers' comp claims. So improving air quality has some side benefits that go beyond the reduction of viruses themselves. With that, I'll turn it over to Randy.
All right, thanks, Scott. So this first slide is just a recap of what we did on site, and now we're working on developing the reports. But really on site is looking at each system individually, because as we talked last week, every building is different, every air HVAC system is different within certain buildings. So we saw, and you'll see in the future slides, we saw quite a range of different air handling and ventilation systems in the different sites that we visited. So we start out with finding as many HVAC drawings as we can. We access the building automation system control design. Many of the sites that we reviewed in the pilot program had standalone essentially controls with Ecobee thermostats. Some of them did have building automation systems that we were able to print off and access the graphics. Review any test and balance reports, and then do a site review with the maintenance team and walk around with them as well to determine if there's any other major issues. But it's really looking at just one quick thing on the last slide, and you don't need to flip back to it. Just in terms of looking at the maintenance and the monitoring, what's available, how do the people maintaining the HVAC systems work? Is there a service contract? So those are the types of things we look at for each building. So next slide. So what we did is for this presentation is just grab a sample from all the sites we visited a couple of weeks ago. 4 of them were part of the pilot program to determine, just to show here's a sample of this, and each building will have an individual report. But what we looked at is the type of the unit. So you can see the number of units that we've reviewed. The upper right is a unit on a portable classroom, and that's pretty typical of those. And those units are typically pretty poor filtering, not a lot of outside air. But we found a lot of issues that need to be resolved as well. The maintenance and filter access. The photo on the upper right side is a picture of the filter access, and the disconnect essentially is mounted right in front of it. So every time they need to change a filter, the disconnect needs to be removed, drop down, change the filter, put it back up. So that's one thing that'd be very easily fixed, is extend the wiring to the disconnect, and we could allow that filter access. The bottom left was interesting because it's a furnace units in a classroom. Each of those furnaces serve a different classroom. But you can see the plywood underneath the furnace. It essentially blocks off all the outside air. So there was no outside air to these classrooms. So that's obviously an important factor when we look at the on-site assessments. And then the bottom right is just the age of the unit. Some of these units are 30 and 40 years old. So that makes a difference in how they can perform as well. And then the middle photo on the right is just the amount of ductwork on a roof. And ductwork on a roof is not necessarily bad, but the problem is that it's acceptable to leaks, to growth. You can see a little bit of moisture sitting on the top of the ductwork. It deteriorates rapidly when it's wet. So that's some of the things we look at. Next slide. So when we look at other things like distribution and building automation systems, so you can see on the upper left, the system was the temperature was currently at 92 degrees. So obviously the system was off, and it was just the classroom essentially, since it was unoccupied, it was essentially let to go to whatever temperature was outside, which leads to some humidity issues in certain cases. And obviously high temperatures. The bottom photo is a photo of essentially what we're trying to prevent, essentially is supply diffusers and return right next to each other. So one of the options here is we put in some ductwork on the supply, spread that supply diffusers out, force that air down before it's allowed to go back to the return air ductwork. I've done a lot of big box stores like Best Buy and other stores like that, and they use this a lot. But even then, they have started to put in ductwork in some of their stores to improve the ventilation in their high bay stores. The upper right one is one thing that we found. So ionization has been added to several units that we found. But this one was interesting because you can see the wire, the green and white wires on the left-hand side of the photo attached to the blue box. The blue box is the ionization unit. But you can see those wires are stretched tight, and essentially the little box to the right is supposed to be in the over the fan inlet. So you can see the wires are too tight to actually mount the unit right. So it's probably not doing a lot of good. And with ionization, the units actually have to be running in order to put ions in the air. So those are just some of the things that we found in regards to those. Next slide. So filters. And I didn't even pick the worst case filters, but it's a good sampling of what we found on site. The middle right column is actually an outside air intake. And this is very common for rooftop units, especially rooftop units close to salt water. Essentially the mesh grid deteriorates very rapidly in salt laden air. So those obviously is a maintenance issue, could be repaired. The biggest issue we saw is obviously the issue with dirt and NOx emissions and brake dust, or just general outside air. And I'll talk to that in the next slide, of the air quality. And the filters have obviously load up very quickly. You can see in the upper left, they're actually being sucked in because they're loaded up. But the biggest issue that we see is bypassing. So the bottom left photo is actually filters that don't fit tightly in the filter rack. So actually any air that passes through goes directly into the coil. If it's not caught by the coil, it goes into the ductwork. If it's not caught in the ductwork, it goes into the airstream and out into the classrooms. In the upper right photo, you can see how much dirt and debris is collected on the coil. Just on the left-hand side of the coil, you can see essentially an inch or two is totally plugged. So essentially all that dirt that's bypassing the filters are getting caught in the coil or downstream. So it's really important that we, as we look at these systems, to look at the filter racks and to look at how well the filter systems are actually cleaning that outside air. As in the next slide, and you can flip the slides, what we tested, I'm going to talk about the filters here first, then we'll jump to the next slide. So just in terms of, just a recap on the filters is the MERV rating. So everybody's heard about the MERV, getting to a MERV 13 or higher in order to start filtering out the microns, 0.3 to 1 microns, which the viruses are in that 0.3 micron range. So you can see also on the right-hand column, once you get to the MERV 13 filter, you actually start filtering out smoke and other things as well. Obviously, when you get to the HEPA class, that's the 95% or better at the 0.3 microns, but you really have to have a MERV 16 filter to do that. And not many air handlers are designed to handle that. Current codes require that new air handlers are designed to at least handle a MERV 13, but we're saying is we should even try and go higher on that to trap those microns or to trap those particles, which would include viruses as well. Next slide. So this is where I want to talk a little bit about the count. So the bottom left is a air quality monitor. That's a portable unit. And we took multiple samples in each building. We took at least one classroom or in different spaces. So we have, I think I have 50 some readings across 4 sites. Just looking at the count, so you can see on the left hand of that meter, it measures down to 0.3 microns. So some meters only measure to 2.5 microns, which really doesn't give us a good indication of the particles smaller than that 2.5 microns. So we spent the extra money, got a air quality meter that actually measures to 0.3 microns, and you can see the counts. Now this is in a preschool classroom. And you can see that those counts are extremely high. Part of it is the outside air counts were extremely high the week we were there. And also if the units aren't running, or if the units are running and there's a lot of bypass, that'll drive those counts up as well. So we've got good baseline numbers saying these counts are probably 4 times higher than they should be. And that's what we're trying to find a solution for, is how do we get these particle counts in the 0.3 to 1 microns about 4 or 5 times lower than what they are showing right now. So that's a challenge. So in the upper left, or the upper photo is actually ion counts. So what we're measuring is the count ions per centimeter. And what we did is measured the peaks. So you can see the peak ion count is, you multiply it times 3, so it's 1900 ions per centimeter cubed. And so what we do is look at, to really get a good ion count, it should be in the 5 to 10,000 range. So it's about half or less of what it really should be. If we have ionization, typically you'd see those numbers in the 5,000 to 10,000 range. So those are some of the things we measure and look at. Humidity, total VOCs are also things that we look at as well when we're doing the air quality testing. Next slide. So just to recap, so I didn't add a lot of existing photos. We have a lot of existing photos of classrooms with ceiling supply grills, ceiling return grills. Obviously, that's not the best choice. We see a lot of short cycling when you get to a distribution system like that. So this is a good graph on the lower 4 examples are ways that we can improve that. One is supplying high, pulling that air across to a low return grill, or supplying low and going the other way and return grills at the top. So either one of those actually pulls that air across the breathing zone and back up across without mixing. The other one is putting in side stream HEPA filtering. So when you have a high supply and high return, like I spoke about, and it has to go across everyone or mixes in the air. Sometimes adding an air cleaner in the classroom is a solution to do that. Or the best is obviously is do the far right is supply high and return through the floor, or go the other way and supply through the floor and return up high. So there's many ways we can improve the distribution system. Obviously that's gets into some capital expenditures because you're changing ductwork and finding ways that you can run ductwork to the floor. or either on the supply or return side. So what we really want to avoid is the dead zones in the corners. We want to make sure there's mixing wherever students or teachers are sitting. So you get that fresh air moving across that zone to eliminate or dilute the particles and the viruses as much as we can. Next slide. All right, so getting to the summary of recommendations. So we took just a sample. We took all the names off each building off of them. So I'm sure if there's people sitting on the from the HVAC team or the facilities team, they probably can tell which ones are theirs. But so we and this is just a start. So there's going to be several other recommendations, but this is a sample of what we call table 1, which is what is immediate recommendations. Things that can be done immediately that really don't need another engineer or a contractor involved. You really can take these and start replacing filters with clean filters. And we note that if the filters are dirty. Changing schedules to start 2 hours prior to building occupancy. We found a lot of buildings that essentially are off and for unoccupied periods, and they don't start till people actually show up. But one of the things that we've been doing is trying to purge, essentially if units have been off for 8 to 10 hours, is actually running those ahead of time to clean out that air in the classrooms before students and teachers get there. So we've been doing that a lot. Some people actually open outside air dampers for that first 2 hours. But the problem is if it's humid or hot conditions or in the heating mode, it's expensive to do that. But just running the systems a couple hours ahead of building occupancy can really make a big difference. You can go to the next slide. So this is table 2, and this one becomes a little bit more complicated because obviously it's tied to capital expenditures. It costs some money to do some of these things, but they're important to do because they have a big difference and they provide solutions to the issues that we're finding. So for example, we won't go through every single air handler because a lot of them are the same, but performing test and balance to verify actual airflows, confirming supply brake fan horsepowers. We've seen a lot of districts across the country just go to MERV 13 filters from MERV 8 filters and without checking fan horsepower or static pressures. So what happens is either you burn out your motor quicker or you reduce the number of air changes an hour in a classroom. And that is probably more detrimental than leaving the filters as is. So we don't want to reduce air changes or reduce the outside air ventilation by putting in higher MERV rating filters. The two should be performed together. So that's why we really want to look at fan motor horsepowers to determine if we can put in higher filters and collect some of that particles and viruses. The other thing is setting district standards for temperature and humidity levels during unoccupied periods. I know that's a lot of districts do that as an energy saving measure. But one of the things that we also see is 92 degrees and 60% or 70% RH in a classroom can lead to mold in a quick hurry. So that's also a thing that we should watch for. And we've developed sequences to make sure that we don't go over a certain temperature or a certain humidity level, RH level, even in unoccupied periods, because it can make a big difference. And then the last point I'll make on this slide is several of the air handlers we know that weren't bringing in enough outside air to meet current codes. So we also put that on the recommendations to rebalance the system to a higher outside air level based on the current ASHRAE standards. Next slide. So this is table 3. This one is obviously the most expensive. Most of it is the replacements are due to age or the inability to filter at a high level, or the outside air is nowhere near where it needs to be. So these are the ones where we look at whether it's an air handler or rooftop unit. The units are 30, 40, 50 years old, and they're due to be replaced. And not only they're due to be replaced, you're probably spending a lot of money on maintenance and other things. And the problem is if they fail and when they fail, the system is going to be down. So those are the time, it's a time then to start replacing these units on a planned basis instead of on an emergency basis. All right, next slide. So wildfire smoke has been a huge topic for everyone across the country. It's everywhere. We've had some extreme outdoor air quality index issues in almost every state, especially in the West, Midwest, with wildfires burning. So I'm not going to go through this slide in detail, but essentially capturing smoke, because smoke's a particle, is in a sense almost the same as capturing a virus. A virus particle is actually smaller than a smoke particle. So smoke particles are easier to recapture, except that if anything is bypassed, you still get smoke in the indoors. So that's one of the things with maintaining filter racks and making sure there's no bypass around the filters. The filters are all tight and they're clean. You can remove smoke particles. I've actually had experience with wildfire smoke and actually outdoor wood boilers, wood burning boilers at several school districts, where we've actually had to go in and put charcoal air filters at certain times to remove actually the smell from the smoke. And they were very successful in doing that, putting in a separate charcoal filter rack and using those charcoal filters when it's needed. So it is able to capture it. We don't recommend closing outside air dampers because then you're just shutting essentially your ventilation off to anyone in the classroom or office. So I know there's a lot of discussion out there now about that, because obviously there's a lot of smoke in the air and a lot of school districts are dealing with that. Next slide.
Randy, it's Richard. Just real quickly, I was just going to do a quick setup for Ron McGuire. Ron's going to talk a little bit about maintenance and monitoring. And one of the things when we got into this was that we got a lot of questions about, well, our maintenance techs and our technician and our team's roles have changed now with COVID. And of course, as the last week or two, the smoke thing has come into it as well. And so it was important to us to be able to spend time with the teams in the field and understand day-to-day routines, day-to-day operating conditions, and what are some of the potential gaps and or skill enhancements that we might want to talk about long-term in the future. And so Ron's going to go ahead and give us a little overview on some of his findings. So thank you, Randy.
Great. Thanks, Richard and Randy. Can everyone hear me okay? I just want to make sure I do an audio check because I am working on it. Good. Okay, great. All right. So good morning, everyone, and thank you very much for spending some time with us this morning, so we can give you kind of some of these key learnings. So my role here is really focusing on equipping our facilities and maintenance personnel with the skills to make sure that they can monitor and maintain our indoor air quality and our systems that support indoor air quality. To make sure that they're, in top-notch conditions. One of the worst things we can do is make changes to our systems, spend capital on these systems, and then not maintain them properly. And then over time, what happens is, that money goes away. But more importantly, you're letting the air quality is degrading over time, which is not healthy for the teachers and students that we're supporting. So what I did is I actually met with several of our maintenance technicians, our trades personnel, and our supervisors. I did interviews. I shadowed them on prioritizing and executing work orders, troubleshooting, and then looked at some of their data collection and records around training and work orders as well. And what my hope is to get really good current state assessment, so that when Randy and Scott make recommendations, that we make sure that we equip our people supporting this with the skills to be able to maintain this quality and improvements. So some of the key findings we had, a lot of variation in the air handling systems, age, condition, even from site to site and within the same sites. And the impact of that for skills is that the more variation you have, the more skills, the more that you need to maintain those systems. So people have to be cross-trained on many more things rather than just a few. And that, of course, is labor intensive and also challenging from a complexity standpoint. We did learn that there have been some recent planned maintenance practices that are instituted, but most of the time, the modus operandi is run to failure. You know, we don't really respond to a system until we find out that it's failing. And then another thing around training, don't have a whole lot of professional skills training and not a lot of formalized or documented on the job training. It's mostly informal shadowing. And a lot of times it's time-based instead of task-based. And what I mean by that is that time-based, sometimes people say, okay, just follow somebody for a couple hours or a couple days or watch them, and then you'll be, you know, be kind of qualified or blessed to do the job. Where task-based is, what does proficiency really look like when I'm performing this task? So there's a lot more documentations and a lot more clarity around what the evaluation criteria should be when you're doing that documented on the job training. Another kind of good thing to see was that most sites have some sort of maintenance management database system. Sometimes it's a, you know, where you're documenting work order generation, closure, and history. So sometimes it's just a off-the-shelf system, it's an in-house built system, or it's spreadsheet based. But the important thing is there's documentation there, and that's very positive. And then the other thing that we're seeing is that there were some cultural and communication barriers between administration and facilities maintenance, which was not unexpected, and it's actually very common. But one thing that I think there's an opportunity for partnership, because really both groups are there to support students and teachers in maintaining optimal air quality to create a good, comfortable environment for teachers to teach and students to learn. Next slide, Rich. There have been a couple places where there have been some more proactive maintenance practices put into place. And what we've seen is an initial increase in cost in those areas, and then followed by a lot of savings driven by higher reliability. So this is something that's caused in the industry called life cycle costing, where a lot of times decisions are made on a very short-term basis based on, hey, what's the cheapest cost to implement right now versus let's think about the next 10 years or 20 years of this equipment, what's really going to cost the most over that time span. What we're seeing is that a lot of times in run to failure or breakdown maintenance kind of models, you save money in the short term, but you definitely lose money long term. I think Richard already kind of identified this, but the pandemic's really stretched the labor of the facilities maintenance group pretty thinly, and people are really responding to shifting priorities very quickly. And we've even seen some of that over the last month, where there's a lot of urgency driven by COVID, and now there's also it's COVID and fires. So there's just things are rapidly shifting, and I think sometimes some of our folks are struggling to respond to that. And then the other thing we're seeing is technicians are really, really innovative at generating low-cost workaround solutions. So there's a great example of where there was a leak under some coils in an AC unit, and instead of the actual vendor didn't make anything for that. So these guys went out real quickly, went to Home Depot and like fabricated as quickly and bent it to where it works. So it was not pretty, but it was effective. So the great news about that is, you've got innovative people here trying to solve problems quickly, effectively, and cost effectively, and make sure that those issues are resolved for the people they're supporting. The bad news is that long term, that creates more and more variation in your systems, and then you don't know how to, you can't really standardize that to repair it. And then the other thing is we're seeing a lot of the variation between air quality monitoring practices and then what distributed control systems. And the reason I'm worried about that is from a skills standpoint, the technology to support this is getting more and more complex. And therefore the skills base that is needed it's a much higher, more complex skills base. So those are some opportunities for standardized work practices where if we could land on 3 or 4 systems instead of 20, that's only 3 or 4 systems that you need to train people on as opposed to 20. So that's another opportunity we see in front of us. So that's it for me, I think. All right, thanks.
Thank you, Ron. That was very, we appreciate that, and especially all your shadowing and riding along shotgun with the folks. So I just want, it's Richard again. I just wanted to give a quick update on AB841 from last week, because there's things going on, and a couple of emails came in from the California Energy Commission yet this morning. I haven't had time to look at them yet, but and my date might be a day or two off here, but the plumbing applications are in fact going live. The actual applications for funding coming up here in the next couple of weeks. And so we'll continue to keep an eye on that. They expect the ventilation applications for the actual first round of funding to be about 4 weeks later than that. And of course, we'll be talking with Jonathan and Teresa, the team at the CEC, and verifying that. We just can't, again, in our conversations, even just last week after the first webinar, we come across different, districts, organizations, whoever it might be, that were not very familiar with the process, and matter of fact, were perhaps hadn't even been registered yet, but then also really not knowing who their underserved schools were. So who is going to get at that first round of funding? Because we know from looking at the numbers, the money available from San Diego Gas and Electric, that there certainly will be enough funds for all of the underserved in San Diego County. So it's crucial to know that. And like Bob said earlier, other updates we will certainly pass along as they come in over the next several weeks, especially the next 5-6 weeks. And that brought us then as just a recap from last week, because we know we might have a few different new people, but just to know that, we had that CBO question last time. How long does it really take to do an AB841 assessment, get your estimates done, prepare your board presentations, get a resolution in front of your board, and then actually get the work ongoing. We know that that's a concern, but it's really a 5 to 8 week process. But here were some of the additional steps, and of course, everyone's going to get a copy of this, and we're happy to take any specific questions on any of this in the Q&A panel. So that's really what we had today. And I know we're kind of booked in at 50 minutes, and we went a little into overtime last time, but Bob, did you want to jump in real quick before we go to the Q&A section?
I do have a couple questions. The first one is, so Randy, I noticed in one of the slides that you had side stream HEPA filters as a potential solution for a particular problem. Would there be a downside to just adding those to every classroom?
That's a great question. We covered it over the last couple of weeks, but the downside is you're going to have a whole lot of these that you're going to have to change filters. So essentially, is what you're doing is you not only have filters at your central air handler system for that space, you're going to add a HEPA filter and another fan. And it's going to have to be maintained. We don't know the lifespan of these HEPA units. I've got 10 of them in our office here. And so we're trying to run them to failure. But there's going to be maintenance on these things. So what we propose, instead of spending all that money, and they're useful, and they can help clean the air in that space. But what we really look at first is improving your systems that you have, your central systems, because those central systems, obviously there's not as many of them, and we just don't want to double up on equipment, double up on fan horsepower if we don't need to. So yes, they will be solutions in some spaces, but we'd rather repair and replace the existing central systems instead.
I'll jump in there also. We also want to be very careful where we place them in the room. They do need to be strategically placed relative to where the air intake and output are in the room, so that we create a sense of laminar flow. To put in a HEPA filter in every classroom in the United States, somebody estimated would be over $1 billion. It is a tool for the right place in the right time, used properly. It's not a fix everything.
Yeah, if you have a poor filter rack and you're bringing in outside air through your central unit, and essentially you're bringing in all the contaminants from the outside air, your HEPA filter is going to load up so quick that it's going to be pretty much useless unless you fix the existing system.
Awesome, thank you. The other question I had is, for months, maybe longer, we've been telling people as kind of a quick solution to maximize the fresh air intake on their ventilation systems. Now that we're deep in fire season, I'm starting to worry about that. Can you talk a little bit about the downside? And so if you don't do that, then what should you do?
Yeah, and I'll start, and I'm sure Dr. Altman will have something too. So what we've seen is districts that are buildings that are adding are essentially opening outside air dampers. Obviously, the heating or cooling season are going to affect that. Smoke, from the wildfires is going to affect that. But what we also see is a lot of these units don't have pre-filters, or the outside air mesh filter is so damaged that essentially all that contamination from the outdoors essentially is just plugging your filters immediately. I mean, some of those photos that I had on the filter slide, those filters were only a month old. And essentially there's so much contamination in the air right now that opening your outside air dampers is just going to make that worse. So that's not necessarily the best scenario, is just to bring in as much outside air as possible, because obviously the energy efficiency is going to be affected, and your number of changes on your filters are going to be affected for each season.
Yeah, I'll jump in there. As Randy predicted, there isn't really a simple fix. If you want to do something quickly, the best thing for you to do is to do an inventory of your systems. Make sure that you have been doing your proper maintenance and replacement of the existing filters, and just get a sense of how tuned up or how in need of repair your systems are. We see people just throwing a MERV 13 filter in to try to increase filtration. And as Randy said, that can decrease the air turnover rate in the room, which would essentially trap virus in the classroom rather than getting it evacuated. So there really isn't a single fix. The best thing to do immediately is to do an inventory of what do you have, what has been done to it, what needs to be replaced or fixed right away, and what can be tuned up.
And I think along with that is to do some indoor air quality measurements. Look at your air quality index, look at your particle counts in the 0.3 micron range, because it really is telling of how clean is your indoor air.
Thank you. Richard, I see a question up.
Yeah, this came in for one of the superintendents last week after the first, or maybe it was actually on one of the assessment sites. But the question was very interesting, and Dr. Altman and I, we had a couple conversations. But they stated, look, we've got a lot of aging HVAC systems here, and how can we use the AB841 assessment to really look at a 10-year plan, if you will? And here's where we'd like to have Roger Savira and Paulo provide us with a little feedback here, and how can we really start to jumpstart our overall infrastructure investment and planning process. Roger, did you want to go first? I know he's there. He's got to come off mute.
Unmute.
Okay, hello everybody. My name is Roger Silvera. I'm the Director of Facilities Maintenance and Operations for Eastside Union High School District out here in San Jose. I'm also a advocate for indoor air quality. I was on the panel that drafted the AB841. I'm a legislative advisor on the Legislative Advisory Committee for CASH. So I'm very involved in air quality in schools. At Eastside, we've been doing air quality long before COVID. And so capital procurement is extremely expensive, buying all this equipment. And so with the introduction of AB841, it really helps with the assessments and develop a long-term plan. And in that long-term plan, capitalizing on your ESSER funds, and there are more funds coming available that will help pay for some of these expensive assets. But we've been plagued for years as school districts with aging equipment, and general funds just don't have the capability of replacing these large capital expenditures. So, some of these funds coming out now, AB841 being one of them, ESSER funds, are essentially one-time dollars, and be able to capitalize on these funds to really put together a long-term plan, replacing some of this problematic aged equipment, and will really help you long-term save energy, money-wise, and just kind of cut down on maintenance costs, relieve some of your labor shortages with your equipment that's really tired and dated and requires a lot of attention. So invest as much as you can long-term. We try to focus on avoiding Band-Aid repairs. And in some of the conversations I've had with the Energy Commission is putting together long-term strategic plans, 20, 25 years out, not just focusing on temporary solutions. And really capitalizing on the ESSER funds, the AB841 funds, and there are different other funds coming available that we'll probably share down the road. But just think long-term, not short-term.
Thank you, Roger. Paulo, did you want
I
to follow?
100% agree with Roger with his assessment. But at the same time, when we start looking at the HVAC replacement, we need to find out within this, I guess these one-time funds, and planning, like Roger was saying, a 20-year plan to replace. How can we also leverage the funds to help us get to a net zero, like the state would like us to get us to, and also DSA? So we need to find that partnership and find that balance in the district where we can purchase the equipment, but yet get to that net zero process.
Randy, did you have a follow-up on that, getting to net zero or any of that as far as your experience?
Yep, that's a good tie-in, because we have the opportunity to obviously improve our energy efficiency when we start replacing some of this aging equipment. There's a lot of things we can do with VAV systems and energy recovery systems. And then that's to reduce the load on the building. But obviously there's a lot of improvements in the refrigerants now, and obviously, and then the other tie into that is, where are we going to produce this energy? Is it going to be PV panels? So we actually, if we're going to get to net zero, we have to have some production on site as well. But we have to reduce the loads from our HVAC systems in order to get there.
Yeah, just like what Randy said. So right now here at Eastside, we produce 7.2 megawatts of solar, and it only offsets 55% of our load. And so we've been looking at energy projects for the past few years, and how we take energy projects that we can create that have positive air quality results. And so we want to eventually get to net zero with the production we currently have, but how do we replace equipment as energy efficiently as possible to get us to net zero? And then also, again, thinking long-term, how do we protect this equipment for the next 20, 25 years? Because many of these funds may never come available again, at least not in my lifetime.
Thank you, Randy and Roger. That was great. Paulo, any other follow-up to that for you, sir?
Actually, no, Roger hit it right on the head. We got to take advantage of these one-time funds. We may never see it again.
Okay, we'll go to the next question then that came in. And this one, came in, I think, on an email or maybe a phone call after last week, was that people wanted to know, well, how quickly can we actually start making changes after we get our assessment report? And if you remember back on the table 1 recommendations slide that we looked at, the real, and I'll let Randy answer, but I know the answer is part of it is that, as soon as a draft report is given, I mean, we have people, in our facilities that are making changes within hours, generally speaking, on the table 1 and table 2, but I'll let Randy follow on that perhaps.
Yeah, and some sites don't even wait. When we're doing the walkthrough through the assessment, if we see something that needs to be fixed right away, typically we let the facilities guys know, and they're fixing it that same day. So you don't even have to wait for our tables and recommendations to come out. We'll point out the major things when we're on site, and they can be resolved the same day. So you don't need to. Those things are simple fixes. They don't cost any money. Typically it's a, setting here or a damper disconnected there that we see, and we'll point those out right away. Richard, I did see a couple of questions coming on the chat, so I don't know if you want to go through those before the.
Yeah, go ahead. No, please. Well, Bob will tell us, give us the hook here when it comes, but go ahead, Randy.
I think, yeah. So this one says, does LifeWings provide project management for upgrades, bid oversight, vetting vendors, installation, project management? And in KFI, we're the engineering side. We do provide all that. We don't push that as part of these HVAC assessments. You can use your regular contractors to do it as well, but we do provide that service. So it's just something that we're not pushing this as we do these webinars. And then the other one was, is it possible to verify our funding amount for AB841 prior to a full application submission?
I'll take that, Randy. Thank you. So yeah, the answer is yes. And we're doing estimates for any number of districts right now and helping them through the application process. And that literally takes, an hour to put something together. And that's very important to do, of course, because first of all, you've got to separate out your schools that are on the underserved list versus your schools that are not. Some districts have almost 100% application, and that's fine, but there are those that are split. And so then those schools would receive the immediate funding on the first round of funding, I should say. And we know in San Diego County, San Diego Gas and Electric, we're fortunate because there's certainly enough on the first round for all the underserved schools. So we'll do the estimate, and then the estimate would include, like we covered last week, the assessment and reporting. It'll also have then the allowance for the one-time additional filters that they pay for, and then also the carbon, the CO2 monitoring, which is the other question I just put up. And lastly, the 20% for contingency fees. And going back to the recommendations, some of this commissioning type work on the table 2 recommendations, the contingency money that you get with your AB341 grant will allow for that. So it's certainly a once in a lifetime opportunity, as both Roger and Paulo have mentioned. And it's a great opportunity not only to make some significant changes and find out what's going on, but you can make some immediate changes before you have to start thinking about your bond money or your ESSER money. Anything else in the chat box? Oops, because I think, okay, Bob.
No, I was just going to say we're good on the chat.
Good on chat. This question has come in at a couple different webinars we've run, is about the CO2 monitors and an overall strategy to use them. Randy, do you want to take this first, and then maybe Roger and Paulo or Scott? Either one, doesn't matter.
Yeah, it's a good tie into the CO2 monitoring. So because of the AB841 allows for CO2 monitors to be paid for. So CO2 monitors is a good indicator of the amount of ventilation air, because essentially what you're measuring, ambient CO2 is in the 400 to 600 parts per million range, depending on where you're at in the country. But what we measure for, and we've seen classrooms, I've seen classrooms up to 5,000 parts per million, because there is no outside air in the classroom and the classroom's fully loaded. So so CO2 monitoring is best done when obviously the space is occupied. But CO2 monitoring also, if it's installed, really should be tied into your outside air dampers, to open your outside air dampers more if the level goes too high. I've seen a lot of CO2 monitors being installed, and they give you a level, but they don't do anything with the HVAC system. So it's important if they're being installed that they actually be used for something that can be controlled. So that'd be my recommendation.
Roger, did you want to follow up on that, on CO2 monitoring at all?
Yeah, I mean, we started monitoring CO2 back in 2018 here at Eastside, and I have an entire website devoted to it because we've been doing a lot of air quality work well before COVID. And I have CO2 monitors. Actually, I have thermostats that monitor CO2, just like Randy said, and they modulate and control the amount of fresh air. And it's helped us with testing, with COVID testing. We've had hundreds of thousands of people come through our spaces for COVID testing, and we were able to monitor and modulate the airflow through our sensors. And the hundreds of thousands of people came through. We haven't had a single case traced back to Eastside, with all these people coming through our buildings. And so they can be very effective as an indicator whether you have good ventilation. And just as Randy said, using them to modulate the air is great. And I have over 2,000 of them right now running across our district.
Thank you, Roger. Paulo, anything else on CO2 monitoring or just monitoring in general as you look to your
No.
goals and objectives?
For us, our goals and objectives here is to get to the point where we are monitoring every single room, especially with the high traffic here at the border here in San Isidro, to try to find out what's going on with all the pollution that's in the air. So our number one goal is to actually serve the students better and serve the faculty better by finding our total CO2s, I guess, in the room, so we can get fresh air in the space.
Thank you. And I think Paulo had a question too about, can any of these funds be used for training our maintenance people in the monitoring piece? And it's a trickier answer, and it requires one of our weekly conversations with the California Energy Committee. So what I'm going to say is I don't know the answer. However, I know with the CO2 monitoring and the setup fees, there might be something there, but there's a number of different funds here. And so let's we'll defer and look at that and plan to email up a follow-up to everybody on that. But that's a great question, Paulo, because again, because the world has changed for all of our techs and our maintenance teams and crews, and their routines are changing. If we could get some help with some of that for that human element, I think that would be great. And so let's plan to do some additional digging on that. That's a great question, Paulo.
Richard, I'll tag on to the CO2 discussion. I think it's important to remember that carbon dioxide is a measurement of what we exhale. It's an indicator of whether there's sufficient air movement in the room and sufficient outside air coming in to dilute the CO2 that we produce. It does not measure volatile organic compounds. It does not measure ions. It does not measure particulates. So it is a tool, but it's not a fix everything. It is just one tool that we need to use to ensure that we have safe indoor air.
Good point.
Richard, we're at about 10:58, so we're a bit over time, but it's been really, I think, valuable. People are hanging in there. We should probably shoot for a wrap up in about 2 minutes.
Oh, you're on mute.
I got it. Thank you. Thank you, Randy. See, I went to touch the chat thing. It didn't advance the screens, but then I couldn't see that I was muted. So I'll get it next time that I won't. Third time's a charm. No touching the bar or the controls for Richard when he's presenting. Hey, I just wanted to say a couple of things. First of all, the sites that participated have been overwhelmingly supportive. And I do want to say this, we have worked over the last 20 years, both Randy's organization, our organization, Dr. Altman and I, in a number of projects at different low income, underserved, wealthy, different kinds of communities. But we've done a lot of work in safety net type communities and in organizations around the country that have had vulnerable populations, whether it's students, parents, adults. And there's a real opportunity here with the safety net and some of these funds available in California, San Diego County, especially with San Diego Gas and Electric. And I think there's a lot of people that we have worked with have been very enthusiastic about the opportunity to provide something better for schools and improve things. So I think, and the other thing is we don't want to forget about the learners, right? Because one of the big things with COVID is people have been stuck in this Zoom and Microsoft Teams world for too long. And so anything that's going to improve the learning environment and help us get caught up, right? I mean, that's one of the things that we talked about when we very first looked at the pilot, is to how do we have a better learning environment so that the students can get caught up and make up for that year that they lost. And we're totally committed to keeping that conversation going in any of this dialogue on this pilot process that we've been in. But everyone's cooperation and participation has just been outstanding. I think there's a real opportunity here in San Diego County.
Well, first off, I want to thank our panel. I think it was a really rich conversation today. I learned a ton. Paulo, Roger, thank you for joining us. Ron, Randy, Dr. Altman, Richard, great job. I will follow up on Monday, sending out the slides and the link to the YouTube link for the recording of this. Please feel free to email me if you have questions or you want to be connected with anybody. I can help you with that. My last request is before you sign off, if you haven't already, please put your name and district or school affiliation in the chat. And thank you for being with us today.
Thanks, everyone. Really appreciate it.